Today we're going to be graphing rational functions, finding their asymptotes and their wholes. This is section 9.3 in the Algebra 2 book. When you graph a rational function, usually you get a graph that has two separate branches to it. This is an example of what a rational function would look like when it's graphed. A rational function graph has what's called asymptotes. An asymptote is the line that the branches of your graph will approach, but they'll never touch. Then you can have vertical asymptotes, or vertical lines that your branches would approach but not touch, or you can have horizontal asymptotes. These are horizontal lines that your graph approaches but never touches. You can have either one or both when you graph a rational function. Now we're going to start by finding vertical asymptotes. To find a vertical asymptote, you look at the denominator and you want to set that equal to 0 so you can solve for x. Sometimes you're going to have to factor your denominator and sometimes you won't have to factor it. In this example, our denominator is x plus 1. If I set that equal to 0, I don't have to factor that. It's all ready to be solved. I subtract 1 to the right and I get x equals negative 1. This is a vertical asymptote, and that means that we would have a line going through x equals negative 1 that our graph would approach but never touch. Take a minute and try to find the vertical asymptote for each one of these examples. Pause until you're ready to go over them. Okay, and number 1, our denominator is x minus 5, so I'm going to set x minus 5 equal to 0, and I would solve for x by adding 5 to the right. X equals 5 is our answer. On number 2, the denominator is x squared minus 4, so I'm going to set that equal to 0. Now this is something that does need to be factored. The factors would be x plus 2 and x minus 2. This is done by the perfect square method. And I set each factor equal to 0, and I solve for x. On the first one, I would subtract 2 to the right, giving me x equals negative 2. On the second one, I would add 2 to the right, giving me x equals positive 2. So this one has two answers, x equals negative 2 and x equals positive 2. On the third example, my denominator is x squared minus x minus 6, and I would set this equal to 0. This is something that does need to be factored. It's a trinomial. And I'm thinking to myself, what multiplies together to make negative 6 and would add up to negative 1? Well, that would be a negative 3 and a positive 2, so the factors would be x minus 3 and x plus 2. Set each one of your factors equal to 0, solve for x. On the first one, we would add 3 to the right to get x equals positive 3. On the second one, we're going to subtract 2 to the right to get x equals negative 2. Okay, finding horizontal asymptotes. The horizontal asymptote rule is to look at the degree or the power of x and fit it into one of these three categories. If the degree of the top is bigger than the degree of the bottom, then there's no horizontal asymptote. And looking at this example, you can see that x squared is a bigger power than x, so the power on the top is bigger, and that's why we would have no horizontal asymptote here. In the middle of our chart, it says if the degree of the top is the same as the degree of the bottom, then we divide to find where the horizontal asymptote is. In this example, we have a regular x on the top, a regular x on the bottom. They're the same power of x, so I would divide the numbers in front of them. 4 divided by 2 is 2, so the horizontal asymptote would be at y equals 2. On the third part of our box, it says if the degree of the bottom is bigger than the degree of the top, then there is a horizontal asymptote at y equals 0, and this is also known as the x-axis. So looking at this example, I have a regular x on top, x squared on bottom. That means the power or the degree of x is bigger on the bottom, and that's when I would say that my horizontal asymptote is at y equals 0, or staying at the x-axis. Okay, take a minute and try to find the horizontal asymptote of each one of these examples and pause until you're ready to go over them. Okay, on the first example, the powers of x are the same on both the top and the bottom, so I would divide the numbers in front of the x's. 2 divided by 1 is 2, and so y equals 2 is my horizontal asymptote. On the second example, the power of x is bigger on the bottom of the fraction, and when that happens, y equals 0 is where my horizontal asymptote is, staying at the x-axis. On the third example, the power of x is bigger on the top of the fraction. When that happens, I do not have a horizontal asymptote, so none would be my answer. Okay, we're going to find the horizontal and vertical asymptotes of each one of these examples. Pause until you're ready to go over them. Starting with the horizontal asymptote for the first one, look at the powers of x. The power of x is bigger on the bottom of the fraction. When that happens, the horizontal asymptote is at y equals 0, or staying at the x-axis is another way to say that. For the vertical asymptote, I take my denominator, x squared minus 16, I set it equal to 0, factor this into x plus 4 and x minus 4, and then solve for x. X equals negative 4, x equals positive 4, two vertical asymptotes. For the second example, the horizontal asymptote can be found by looking at the powers of x. They're the same. When the powers of x are the same, we divide by the numbers in front of them. 1 divided by 1 would be 1, and so y equals 1 is the horizontal asymptote. For the vertical asymptote, I want to look at the denominator and set it equal to 0. X squared plus 3 equals 0 is something that doesn't factor, and so I would say none for my vertical asymptote. There isn't one. For the third example, look at the powers of x for the horizontal asymptote. The power of x is bigger on the bottom, so y equals 0 is my horizontal asymptote. It's staying at the x-axis. For the vertical asymptote, I take my denominator, I set it equal to 0. X squared plus 2x minus 8 equals 0 is something that can be factored. The factors are x plus 4 and x minus 2. If I set them equal to 0 and solve for x, I get negative 4 and positive 2. So the vertical asymptotes are at negative 4 and positive 2. Now, a hole in a graph occurs when a rational function has a factor on the top and on the bottom that are the same factor and cancel out. Instead of there being a vertical asymptote at that value of x, there's a hole instead. And this picture shows you what a hole in the graph would look like. Now, your calculator will not show you where a hole in a graph is. It's something that we just kind of make a mental note of and draw in ourselves as we draw a picture of the graph. Looking at this example, x minus 3 appears on both the top and bottom of the fraction. So that factor is going to cancel out, and instead of there being a vertical asymptote at x equals 3, there's a hole in the graph there. So what you do is you go over to x equals 3 when you draw your picture, and you just put a little hole in your graph, just like I did here on this picture. The other asymptote at x equals negative 2 is still going to be a vertical asymptote there. That doesn't change. It's just that we don't have a vertical asymptote at 3 because of that factor canceling. It's a hole instead. So holes occur when the factor on the top and bottom cancel. Find out what x is equal to, and then that is where your hole is.